In this video, we're going to talk about how to get the integral of a cosine function. So suppose that you're given a cosine function and it takes the form cosine, it takes this form right here, and don't worry too much about what this means. We'll get to that as the video goes along. But if you ever get a cosine function, the integral of it will give you a sine function. Okay, so essentially what happens is whenever we're given that cosine function, what we want to do is we want to put it in this form, and then once it's in this form right here, it allows us to convert it directly into a sine. So let's talk about how that works with an example. So let's say we have a function f of x is equal to cos 7x, right? And you are asked to find the integral. Okay, find the integral of f of x dx. So how would we do that? Well, this box here, okay, this is a placeholder that we use to make our integration easier for us. Okay, it allows us to manipulate our integrand so that we can convert it directly to this. So let's talk about how that works. So this placeholder here, this box, just represents whatever is in the cosine bracket. In this case, it's 7x. So let's write down our placeholder here. So 7x, and then the derivative of that, so d box by dx, okay, is equal to, by dx is equal to the derivative of this with respect to x, which is just 7. So that's the first step. Now what we can do is we can go ahead and evaluate this integral. So what we're looking at, okay, what this question is asking us is f of x dx, the integral of f of x dx, which is the integral of cos 7x dx. That's the setup right there. So how do we find that? Well, what we want to do before we convert this integral, because we can't do it directly, we have to put it into this form here. So what we're going to do is, you're going to do our substitutions here. So cos, whatever this box is, okay, dx. All right, as you can see, we have a dx here. What we want is we want to be differentiating with respect to this box here. Okay, we want this to be with respect to this box, or excuse me, we want to be integrating with respect to this placeholder here. So to do that, we simply multiply this, okay, right here, by this expression here. So what we will get is the integral of cos of our placeholder box times the derivative of our placeholder with respect to x dx. And as you can see, you can sort of visualize it as these dx's canceling out. So now it's in a form where we can integrate with respect to the placeholder. So if we put our numbers in though, this is what we get. We get the integral of cos 7x times 7 times 7. Okay, so that's our d box by dx, dx. And as you can see, this is in a good form to finally integrate it. The only problem is though, is that since there's a 7 here, this is a completely different expression than this, because that's 7. It's not the same thing anymore. So to remedy that, a creative way of doing it is just by adding a 1 over 7, or 1 over 7. What that does is these 7's cancel out. And then a cool thing we can do is we can take this 1 over 7 out of the integrand and write it this way. 1 over 7 times cos of 7x times 7 dx. And now we are ready to integrate it. This is the ideal form, because this right here, this entire expression hasn't changed from this, okay? It's still the same thing. Okay, this still equals this. These 7's cancel out and we're left with the cos 7x dx. But on top of that, this is actually in a form where we can integrate it directly. We can convert directly from this form to this form here. So that is the ideal integrating format. So what we can do then now, okay, this equals 1 over 7 times sine of whatever is in this box plus c. So sine 7x 7x plus c. And that is our answer.